Our last type of equation to solve and our last thing to review is solving logarithmic equations. All right, logarithmic equations, of course, when there's a log in the problem, and our two strategies are really similar to exponentials. Exponentials and logs are inverses, so their strategies are pretty much related. All right, if there's a logarithm on both sides, you can simplify it down, and then once you get a single log, you can cancel them out. If there's only one log in the problem, then you're gonna have to switch to an exponential to figure out x. For logarithmic equations, always make sure to check for extraneous roots at the end. When we talked about domain, you can't plug in certain values into a logarithm, so make sure your answers still fit that criteria. So if I look at this problem, I'd say I have logs on both sides, so that I can combine into a single log on both sides, which I can, because if I add two logarithms together, I can smush them together and multiply the insides. And now I have a single log on each side, so I can cancel out the log and just look at the inside. Also distributed this x in. Right, and now I just had this quadratic equation to solve. Right, so I went from a logarithm equation. By using the one-to-one property, I canceled them out. Now I have a quadratic equation. Move everything to one side. Factor. Set the factors equal to 0. All right, and the last thing I had to check. All right, make sure there's no extraneous roots. All right, -4. I can't plug in here because I can't plug negatives into a logarithm. So -4 I just have to cross out as a possible answer. And only 1 actually works. Actually, I lied. 1 doesn't work either because 1 minus 4 is -3. And also couldn't put -3 into a log. So actually this problem has no solution. I didn't realize this originally. This problem has no solution because both these possible solutions don't work in my original equation. Here, there's logs on one side but not the other. So we're going to solve this one slightly differently. I still need to combine my logs. I'm still going to combine these logs. There's a minus sign, so I can divide the insides. But now there's not a log on the other side, so I can't just cancel out the logs. But what I can do is switch to an exponential. And the exponential is the base is 2. I raise it to the third power over here. And that equals the inside 3 over x. All right, so this is switching to an exponential. And you can see the x pops out of the log. Now to get rid of that, that's 8. I can multiply both sides by x to get it out of the fraction. And then divide by 8 to get my final answer. 3/8 does work in here because it's a positive number. So my answer is 3/8. All right, so logarithms, there's a lot that goes into it. It's actually like these log rules to combine them. This is the main strategy of combine on both sides to get rid of the logs, or combine and switch to an exponential. Those are your two main strategies for solving logarithmic equations.